Okay, question 14a. The function 2 to the power of x plus 2 to the power of negative x, show that it is even. So we're going to sub in negative x. So we get 2 to the negative x plus 2 to the negative, I'll never get it, negative x, which is 2 to the negative x plus 2 to the positive x, which is, let's just rewrite it, and you can see that that is the original function, therefore it is even. Now, probably the best way is to graph this is table of values, negative 3, negative 2, negative 1, 0, 1, 2 and 3. So if you shove in 0 into the original function, 2 to the power of 0 is 1, plus 2 to the power of negative 0 is 1, so you get 2. 2 to the power of 1 is 2 plus 2 to the power of negative 1, that's a half. So we've got 2.5. 2 to the power of 2 is 4. 2 to the power of negative 2 is a quarter. So we have 4.25. 3 to the power of 2 is 8. Plus 2 to the power of negative 3 is 1/8, which is 8.125. Now, if you sub in negative 1, it just switches everything around. So it's going to be positive 2.5, positive 4.25, and positive 8.125. So it's actually got symmetry. So therefore, there's my 2, which is my intercept, and it goes up a little bit this side, symmetry this side, then a little bit more at 4.25, then 8.125, and so you can see basically, not very good there, but okay, so show that the quadratic roots are real and different. Okay, so we're going to do the discriminant. So we get b, which is k plus 2 squared, minus 4 times 1 times k. K squared plus 4k plus 4 minus 4k, k squared plus 4. Just they cancel each other out. Now, k squared will always be positive, so you add 4 to that will also be positive, so therefore that has to be greater than 0 no matter for all real k. So therefore the roots are real and different, because they're equal when it's 0, but this is greater than 0. Okay, show that this line is a tangent to the circle. Now, there's basically 2 ways to do this. Now, the first way is you can use the fact that a tangent is a perpendicular line to the center of a circle, so the distance should equal the radius. So if we do that, we have to complete the square to make the circle. So we get x squared minus 4x plus y squared equals 0. So let's complete this square. Half of 4, because normally it's double the product, so we're going to half that, you get negative 2. Now this, when you expand this, you'll get positive 4. So therefore, if you got a positive 4 this side, you actually need a positive 4 that side to balance it out. So therefore, you'll see that the centre is 2, 0, 2 with the x and 0 for the y, and the radius will be square root of 4, which is 2. Now if we use the perpendicular distance formula, a, which is 3, times x1, which is 2, plus b, 4, times y1, plus c, which is negative 16, the absolute of that, over a squared plus b squared, which is 3 squared plus 4 squared, which equals, we get 6 minus 16 equals negative 10, all over square root of 25, which is 5. Absolute of negative 10 is positive 10 over 5, which is 2. And you can see that the radius is 2, so therefore the radius is equal to the perpendicular distance, so therefore it is a tangent. If the distance there would be more than 2 or less than 2, it wouldn't be a tangent because it wouldn't equal the radius. Now the other way to do it would be simultaneous equations, where you could rearrange the straight line to let y equal negative 3x but divided by 4, and positive 16 divided by 4, which gives you 4, and you sub that in to there. What you get is a quadratic formula, and then you can talk about the discriminant, and because it's a tangent, that means it only hits once, therefore it will only have one root, which means the discriminant would have to equal 0, which it does. So that's two ways you can show. Okay, for D. Alright, we want to know the equation of the tangent to this curve. So, at x equals 1. So we firstly need to work out the gradient, so therefore actually before we do that, let's rewrite. So we get to the power of a half, and we get x to the negative 2. So now we find the derivative, so we get half x, and we reduce the power by 1, so we take away, minus 2x, and take away 1, we get negative 3. Now if we sub x equals 1 into that, 1 to the power of anything is still 1, so we get half minus 2 times 1 to the negative 3, which is still 1, so therefore that is 2. So we get negative 1.5, which is negative 3 on 2. Now, also when x equals 1, we need to find what y equals from the original. So the square root of 1 is 1. 1 over 1 squared is 1. 1 plus 1 is 2. So now we use the gradient point formula. Y minus 2 equals negative 3 on 2, because it's a tangent, so equal gradient, x minus 1. Now let's multiply by 2 both sides to get rid of that denominator, so 2y minus 4. Now expand the bracket, negative 3x plus 3. General formula, let's bring out the negative 3x over the other side, so therefore 3x plus 2y is already there. Let's take away 3 from both sides, and equals 0. Okay, so in the diagram, it's a square, so 2, 2, 2 and 2. E is on the point, so that ABE is an equilateral, so therefore if that's 2 down the bottom, these also have to be 2. Okay, so therefore find the angle ECN. So we need to find ECN. We need to find that angle in there. Now don't assume that that is a right angle, because it is not. Okay, so because it's a square, that is 90 degrees. So angle ABC equals 90, because it's a square. This is equal to 60, so angle ABE is equal to 60, because it is an equilateral triangle. So therefore, angle EBC is equal to 30. Okay, now, because we know that's 2 and that's 2, it's an isosceles triangle. So therefore, triangle BEC is isosceles. So therefore, angle BEC is equal to angle ECB, because angles opposite equal sides are equal. So therefore, BEC plus ECB plus 30 must equal 180, because we've got an angle sum of triangle. So therefore, because they're the same, ECB or ECN, I'll change that, must equal 150 divided by 2, which equals 75 degrees. Okay, now part 2, hence show that tan 75 is 2 plus root 3. So we know now that that is 75. Now, I think we can pretty much assume that that has to be 1, because it's halfway between, that's the midpoint, and it's 2. But if you just want to do that quickly, we've got a right angle triangle just here with the 30. So we could just use the 2 for EB. So we could say that that is sin 30 equals x over 2 times by 2. Sin 30 is actually equal to a half. So x is 1. So because now we can use, BN, we can use Pythagoras, so BN squared is going to equal 2 squared minus 1 squared, which gives us 3, so BN is the square root of 3, so therefore CN, that little bit just here, it's 2 all the way, so it must be 2 take away root 3. So now, using that, tan 75 is opposite, which was 1, over adjacent, which is CN, which is that. Let's rationalize denominator by doing the conjugate. That's 2 plus root 3. So we get 2 plus square root of 3 on top, over 2 2's are 4, minus root 3 times root 3 is 3. So that equals 1 on the bottom, so therefore that is equal on the top. So tan 75 equals 2 plus root 3.